So let's again follow up on our main entry point, which was driver CPP, right? So we were trying to see what's going on when we say factory instance, and we can go to this factory instance. Okay, so this is again this just happens to be a global function, right? Essentially a utility function in the system that simply says if you want true or false, there's a input parameter here for factory instance. If it's true, then we create bombed factory, which is capable of producing a special type of walls. Otherwise, we just construct the maze factory like this. And I'm trying to simplify this as much as possible. Now, interestingly, there is only one reference in the system that keeps the factory instance. In fact, we don't want to produce, when we call factory instance, the design here says that we don't want to produce too many instances of factory. So in fact, it basically checks whether this factory instance, which apparently is non-existent, right? We could have shown it like this. So we say if factory instance is still a null pointer, then only then create it. And create it based on this Boolean variable that says if you want the bombed wall type of factory, say bombed maze factory. Otherwise, create a simple factory. In fact, I think that that's exactly what we did, right? We just said we want a factory bombed, which is set to false, so we do not produce a bombed factory. We produce this simple factory. Right, so and then there's also an overloaded version of this factory instance method, which basically calls factory instance with false, right? So there's just basically no parameter version of it which calls this specific function and says just produce this one, right? Because it's just gonna check whether it's true or false right here, and if it's false, like this one wants, then this maze factory will be produced. There's an extra semicolon over there. So this thing here is called a factory method. Essentially, the method or function in C and C++, which creates a specific type of object. Apparently, the user, the client, such as main and other parts of the system, may want to be able to say, give me instance of a factory. It will be created only if it hasn't been created yet, right? And the constructors will be invoked for these specific two types. All right. So how can we in UML, how can we document what we see over here? In UML, typically what happens is that you go to your UML diagram. Okay. And let me update my parameters here for my image size. This image size is going to grow sort of like enormously, so I'm just going to make it 4 times wider, like this. So I have some space, and in fact I would like to save it so that I don't want to lose it. This is our project, and our project is here, and I can save it somewhere. Okay, so I saved it. Anyway, so I have more space, and like I said, I would like to do something about documenting what I see. Normally in UML, what you can do, especially if you work with Java, if you're planning to do some Java programming, you can create some sort of utility class, right? Oops. some sort of utility class. Where basically you will keep track of these things that we do. For instance, factory instance, right? Factory instance. The type of it is Maze Factory. Okay, the type of it is Maze Factory, and we would like to indicate that this doesn't belong to any objects, right? This is actually a global variable in this application. In Java, you make global variables by making them public inside of your utility class, and UML has notation for it. You can actually use underscore, right? And in fact, let me just use like slightly different color for this underscore, right? If it appears to be with underscore, it basically says this is a static. This is in Java it would be static. In C or C++, this would be just a global variable. Okay, and by the way, over here I should get rid of this line because these are my data attributes inside of a utility, right? So the second line will appear somewhere lower. Okay, and I have a couple of these factory instance. So now it's time to draw this line. I draw this line, okay, and then say this is factory. Factory instance, and of course it returns back a Maze Factory. Okay, so it returns back a Maze Factory. All right, so this is the box which represents the set of utilities, right? I will spare myself from like specifying the second one. It's really not very important right now. Just want to keep like big picture of everything right now, so this is what you can do to document this part of the system in UML. Right, so I'm just going to fill this with the same type of color we used everywhere else, right? And so again, you can see that now I actually added utility class to my diagram. If I want to move it, I can always, using your more sophisticated diagramming tool, you can move it someplace else when you want, right? So, oops. Okay. All right. So anyway, this main driver actually creates a specific instance of a factory, which is remembered by this Maze Factory pointer named a factory. So now it's of course is the time for us to look at what we have here. So we have Maze Factory, but we also have observed that inside factory instance, over here, this method, there is also bomb Maze Factory. All right, so let's find it. So somewhere here, there is a header file, right? So somewhere here, there is a header file. Let's open the header file. Right. So that says bomb wall. That's the wrong one. Okay, here. In this header file, let me resize it. We find another class declaration which says bomb Maze Factory, and it also inherits from the Maze Factory. So let's document this part. Right. So we have the Maze Factory. Now we have another class. We have another class right here that says bombed. Okay, that says bombed Maze Factory, which inherits from the Maze Factory, right? So So this is the bombed version of it is another class, and it has the constructor, and it has MakeWall, because making wall at the bombed maze factory is different. Okay, apparently different type of wall will be manufactured if we do something like this. So bombed maze factory, by the way, also a class that doesn't have any data, right? It just has a constructor, which again I will draw as new, right? So it has constructor new, which produces the new object. It has the destructor, which I at this point will ignore, and it has MakeWall. MakeWall, right? Which obviously returns the wall, just like we already saw in the maze factory. Obviously, this is an overloaded method of MakeWall, the same one, but overloaded, because we want to do something different if the factory was bombed maze factory and not the regular maze factory. And there's also print, like everybody uses print in the system, so there is print that can visualize what this thing is, right? So let's add this box, right? And hopefully I can again fill this in so that we can be consistent with what we do. Okay, and so now we see that we have those two which derive from one another. Bomb maze factory derives from the maze factory and overloads the MakeWall, right? So I keep adding these classes to my basically to my system, and what I'm thinking right now is that it would be beneficial perhaps for me to be able to go over here and just open it in the viewer, right? So that in the viewer I can basically see the in the viewer I can basically resize things and make everything, you know, more or less viewable in one piece, right? So we can use different view over here, right? So object is what everything derives from. It has unique ID. Maze game can create a maze, right? A maze factory has the method to actually manufacture the maze, create wall, create room, create door. Bomb maze factory is subclass of the maze factory, which overrides MakeWall and can create a different type of wall. Let's take a look at the this version of MakeWall. Okay, and apparently it's somewhere in the implementation of Bomb Maze Factory. So if we compare the two versions of MakeWall, so this is the version of MakeWall which the Bomb Maze Factory has. It makes bombed wall. If we compare it with Maze Factory, do I have this file open somewhere here? mazefactory.cpp. If we look at the implementation of this method in the Maze Factory, MakeWall, you see that it manufactures a regular wall. So if we do look at the wall, and I will go to the declaration of the wall, so that's perhaps something else for us to go ahead and document, right? So we can scroll down and we can say that, we have the wall class. Let's just resize this, right? So we have this wall class, wall, which basically has the constructor. I don't think it has any parameters, so this will be just a constructor right here, new, right? And it has an enter. So apparently enter is something that So you can imagine that if we have a room, right, in, say, in 3D space, and so some rooms can have doors like this, right? But some rooms can have bombed walls. So, right, so they can be essentially, you can enter through that type of wall. And so that's the idea, that even though it's a wall, there's an idea of entry through, even if that's the case, right? So that's fine. So that's why we have the enter. And for everything in the system, we have a print method. Print, okay? So that's the print method right here. All right. So that's a very simple idea of a wall right here, wall class, right? And we immediately observe that the wall is deriving from the map site. Okay, and by the way, if we go back to the to look at the inheritance diagram, you can see that here's our wall, right? The wall class. It derives from map site. In fact, the door, the room, the wall, all kinds of parts of the room actually derive from the map site, because apparently it's convenient to be able to get them organized in simple collection, and they all can be stored as references to the map site. So that's an interesting observation. So let's take a look at the map site. What is it? Map site. Map site is a class which is declared in its own header file right here, right? So again, there is an enter, there's print, and there's also a constructor which is protected, which means that it can be used only, which makes map site non-creatable, right? Only the objects that derive from map site can use its constructor. So let's just quickly add the map site to what we do, right? So the map site. Map site is essentially another helper class which really doesn't do a lot, but it does provide the interface such as enter, right, and print, and all sites of any room apparently have to be deriving from the map site, because that's just going to be the requirement in the system in order to keep everything properly organized and so forth. So here we go, right? So a map site, and so the map site becomes the superclass for any kind of site that can be used to construct a room. Okay, and by the way, all of this becomes more or less visible, right? So I just keep adding these things over here. This is going to be a big, apparently a kind of a large set of UML classes, because that's a big, relatively, big code base here that I need to work with. But once again, if I just build this once again, and run this, you can see that what happens here with here's the demonstration. When we have a maze that has collection of rooms, and it keeps track of rooms through an object array. An object array contains one room, and then later on over here another room, right? And each room has these map sites, which are wall, door, and wall. And each wall, door, or another wall, right, is actually a kind of map site, right? So this is where we're gonna add. Let's just quickly add those two other types. First of all, we have, again, I can take a peek at this. The room itself is also a map site, because just for the sake of convenience, also the room can have doors and walls, right? So let's just take a look at the room. So these are very simple objects, right? So if we take a look at the declaration for the room class right here, right? The room class also derives from map site, right? So it has the constructor and so forth. Let's just quickly add this up to what we do, right? So the room we can document as, right, another class we have in the system. Room right here. It has pointer to object array of sides. That's fine. In fact, I can simplify this a little bit. And it has the room number, right? So we have the room number, which is basically some sort of internal ID, which is an integer, right? So in the section of data attributes for the room class, we have this integer that says room number. Then, of course, we have the constructor new, right? New constructor, which takes a room number, n, which is the integer, right? So the constructor requires that the room number is provided when the object is constructed. Again, I largely ignore the constructors in this application. We have naturally get side and set side, enter in print, right? So right now I don't want to go through a lot of details about why we need get side and set side. I will just document this as we go, right? So there's a get side, there is set side, there is enter, which is quite natural for the maze type of application, and there's also print, right? Print, right? So get side tells get side right here says which direction. Apparently, for the sake of simplicity, instead of like all kinds of compass direction, this one will be using just east, west, north, or south, as far as I can remember, right? So so direction is basically just for now direction can be one of these four. It's just another type of integer, or actually we can say that this is an enumeration, right? There's enumeration of east, west, south and north, right? And set side will be basically doing similar stuff. I'm not going to waste my time with this. So this is the idea of the room, that the room can be configured with sides, and sides can be walls, right? Walls and doors, right? So this is what the sides are, walls and doors. All right. Okay. So this is the type of room, and we said for the sake of possibility of putting all of this into some sort of collection, a room itself is also a subclass of the map site. All right, so if I save this, you can see it over here in more of a kind of like general view of everything that we do. Okay, so wall and room. We also need to document the door, right? So that the door is another class we want to document. Here's the door, right? So let's save this segment.